Now this video is about different cycles in the atmosphere. Now these are biological or biochemical processes, and there are obviously three main cycles that we need to know about. Water cycle, which we already know, is that water exists in three different forms: steam, liquid water, and ice. And it doesn't need any introduction, and it doesn't have much application in chemistry syllabus. The other two cycles, the primary one, which is carbon cycle, and you know that carbon is the foundation of all life on earth, and it is present in complex molecules including proteins, DNA, and they give rise to life. And not just that, it is also important for other biological processes in the atmosphere, and that is why we have to understand that there are four processes that regulate the amount of carbon or carbon dioxide in the atmosphere. It's mainly present in the atmosphere as carbon dioxide. So all the processes that increase the amount of carbon dioxide in the atmosphere, we call them carbon positive processes. And there are three of them that we need to know about. The first one is, as you know, respiration. What respiration does is that in our cells, we have a mechanism by which we take glucose, which is the main form of energy for organisms, and glucose reacts with oxygen, which we inhale, and our lungs allow us to get this transported from through blood to the cells, and this uses this in an exothermic reaction, creating water and carbon dioxide as a result, and this is the balanced equation for that. Now this is increasing the amount of carbon dioxide in the atmosphere because carbon dioxide over here is the product. Similarly, you can also have another process which also increases the amount of carbon in the atmosphere, which is combustion. Combustion is another name for burning, and it's the chemical process by which different fuels that contain carbon are burnt. Now, all fossil fuels contain carbon. So let's suppose we have methane, which is the primary component of natural gas. Now, when methane burns, it produces carbon dioxide and water. And this process is again carbon positive, and if you balance it, this is how it comes out to be. And it is also increasing the amount of carbon dioxide in the atmosphere because, as you can see, carbon dioxide is in the product over here. Similarly, you can burn pure carbon as well, which is primary component in coal. So if you burn pure carbon, again its reaction with oxygen in presence of a flame creates carbon dioxide, and if enough oxygen is not present, then this process creates carbon monoxide, and carbon solid will simply be burnt if you have even less oxygen present, and this will be converted to carbon in the gaseous state, and this we call, sometimes carbon solid is just emitted out, and that we call soot. Now the important thing to remember is that all of these processes are exothermic, but this is the most exothermic of these, and then this is less exothermic, and this is even less exothermic than this one. So providing more oxygen is always beneficial if you're using a fuel and fuel efficiency, but regardless, all these organic compounds that you burn or all these fossil fuels that you burn are increasing the amount of carbon dioxide in the atmosphere, and not just carbon dioxide, they're also giving rise to other harmful gases like carbon monoxide, as you can see over here. Now, what's the problem with that? Carbon dioxide is a greenhouse gas, and greenhouse gases are able to store heat for a longer period of time than other gases, which means that a higher amount of carbon dioxide in the atmosphere will increase the heat stored in the atmosphere, and that will lead to an enhanced greenhouse effect. We need greenhouse effect to maintain a certain level of temperature, climate, to maintain the weather and all life cycles and everything, but a higher than necessary will obviously affect the sustenance of many animals and plants, which is already happening as a result of human activities. Then there is another process which also increases the amount of carbon in the atmosphere, and that process is decomposition of limestone. Limestone, as you know, is calcium carbonate, and when calcium carbonate breaks down, there are multiple reasons why it breaks down. It can break down under the influence of heat, it can break down if there is an acid present, and it breaks down to form calcium oxide, which is called slake lime, and carbon dioxide, which is given off into the atmosphere. Now, where does this happen? Limestone is present in many underwater mines, underwater rocks. It is also the primary component of chalk. So there's chalk rocks, which are present, which have calcium carbonate in them. So when you have more carbon dioxide in the atmosphere, that carbon dioxide can dissolve in water and produce carbonic acid in a reversible reaction. So this carbonic acid can then go and react with calcium carbonate, and it can basically break it down into carbon dioxide and calcium oxide. The actual mechanism as how this happens is slightly different because there are ions involved like hydrogen carbonate ions, which we don't have to go into detail of, but it's important to understand that when water containing carbon dioxide comes into contact with limestone rocks, the rocks dissolve, and that basically creates carbon dioxide, which is given off into the atmosphere. So a changing pH of ocean water or a changing pH of water bodies that are in contact with calcium carbonate rocks is obviously damaging to the environment because it increases the amount of carbon dioxide in the atmosphere. So there's three processes that are increasing the carbon dioxide, and there's one process that can counter effect, and that is photosynthesis. Photosynthesis is an endothermic process, and what happens in photosynthesis is that you get carbon dioxide, and plants have this whole mechanism by which they do this. So you take carbon dioxide and water, and it's then converted using sunlight, which provides the activation energy required, to glucose and oxygen. As you can see, this is a process in which carbon dioxide in the atmosphere is being utilized or used up. And that is why we say that this is a carbon negative process, because it reduces the amount of carbon dioxide in the atmosphere. And if you balance it, this is what comes out to be. So we have four processes that affect the amount of carbon in the atmosphere. And obviously the primary component of carbon is carbon dioxide. Now, on the topic of limestone, we also need to know about lime family. Lime family has four main components or four main members. They are calcium carbonate, which is part of limestone. We have calcium oxide, which is called quicklime or just lime even, and it absorbs carbon dioxide from the atmosphere to make limestone again. We have calcium hydroxide. And calcium hydroxide exists as two forms. One is when it is solid, and in that case it's called slake lime, and it is used by farmers to fix the pH of the soil because this is alkaline and it's slightly soluble in water. So when it does that, and if the soil is acidic, it will react and it will basically fix the pH of the soil. But a saturated solution of calcium hydroxide in water is called lime water. And lime water is used to test for carbon dioxide. And this is an important positive test for carbon dioxide that we need to know about. So that's the lime family, and we need to know about uses of each one of them. Now we need to move on to nitrogen cycle, which is the last cycle in our syllabus. So nitrogen cycle, while there's a lot of detail of this, and if you're taking biology, you might know that this biochemical process has a very important role to play in the lives of plants and animals, but we don't need to go into that much detail for now in chemistry. In chemistry, we just focus on a few things. Number one, we need to know that nitrogen is the most abundant gas in the atmosphere, and we say that this is present 78% in the atmosphere. People who study IGCSE can use 79 or 80% even, and both of them are acceptable for IGCSE, and 78 to 79 is acceptable for O-levels. Then we need to know that this nitrogen, because of the triple bond in nitrogen molecule, it's very inert. It does not react as much. And the reason is that the bond between nitrogen and the other nitrogen, this triple bond, is really, really strong. So it's difficult to break. So plants, when they try to do photosynthesis, while they can break the bonds between oxygen molecules, they cannot break the bond between nitrogen. And even though nitrogen, phosphorus, and potassium, these three are important nutrients for plants, they are not able to get nitrogen from the atmosphere. So they have to rely on nitrogen cycle to get this nitrogen. So what happens is that in presence of high energy, this nitrogen molecule can break down and form other gases, which are then used to form important ions for plants. So where do we have high temperature? So we have high temperature in lightning activity, if there's lightning activity, or inside the internal combustion engine, which we call ICE. So internal combustion engine. This is the engine that we have in most vehicles. So this is where there's high temperature, and nitrogen from the air gets to break down. And when it does that, it reacts with oxygen, producing nitrogen monoxide. Nitrogen monoxide is a neutral molecule. It is not acidic, it's not basic, but it can play a role as a catalyst when it comes to production of sulfur trioxide in the atmosphere. So this is a catalyst for SO3 in atmosphere. And you know that SO3 is important when it comes to acid rain. It can cause acid rain by dissolving in water. So letting nitrogen monoxide go up in the atmosphere is very dangerous because it can cause, while it does not directly create acids or acid rain, it can influence and can speed up the process of sulfur dioxide forming, which can then be causing acid rain. Similarly, this nitrogen monoxide can react with oxygen in a reversible reaction and produce nitrogen dioxide, which is also used to oxidize sulfur dioxide. And nitrogen dioxide is an acidic gas itself, and when it dissolves in water, it can also cause acid rain. And then a host of the other reactions happen, and this nitrogen can then be converted into ammonia, which can then be converted to ammonium ion. These two are important components containing nitrogen because ammonia is primarily used to create fertilizers, and it is created through or using the industrial process of Haber process. Now you might be familiar with Haber process. There's a separate chapter on it, and we have studied about it in a separate video. So this is the Haber process primary equation, and here nitrogen is gotten from the air through fractional distillation of the air, and hydrogen is gotten through catalytic cracking of hydrocarbons. Again, ammonia, you need to know the test for that, and it's an alkaline or basic gas. Ammonium, on the other hand, is acidic. The reason is that ammonium has H positive that it can lose, and ammonia does not have that, so it can accept H positive, which is why ammonium, when it reacts or in the influence of heat, ammonium can break down and form hydrogen ions, which means it's an acid, and give off ammonia, which goes out in the atmosphere. Now, the important thing to remember here is that ammonium, which is present in many fertilizers, should not be used with calcium hydroxide. Reason, calcium hydroxide is basic, ammonium is acidic. So if the fertilizer has ammonium and you add calcium hydroxide to it, basically they will react and release ammonia out in the atmosphere. So plants would not be able to get this nitrogen. Of course, this nitrogen is then used by plants to make proteins, and then as they decompose and all that, there is ways by which this can go back to the nitrogen in the atmosphere. Again, those are not in our syllabus of chemistry, and you can study more about that in bio. But for now, we just need to know that ammonium ion can release ammonia in the atmosphere, especially if you heat it or if you add basic substances to the soil. So it shouldn't be, if you want to fix the pH of soil that is acidic, you should not be adding ammonia because it will make it more acidic. But you shouldn't, if you want to use ammonium salts as fertilizer, you shouldn't be adding calcium hydroxide at the same time because it will release ammonia to the atmosphere and the plants will not get any nitrogen. So those are the important facts to remember about nitrogen, carbon, lime family, and water cycle, and I hope you understand them.